Welcome, everybody. Another Service Mesh Academy. We're here at the end of the year in December, and Santa has come down the chimney with some gifts for you. And in that, I mean,
This is why we don't do comedy for our day jobs.
we have a new release that we got out right around the time of KubeCon. It's 2.17, and there are some great gifts under that tree. So I'm going to go ahead and turn it over to Flynn, and he's going to tell you what came down the chimney with Santa.
And Tom, I shall actually, you know what? I'll do it myself because I can do this.
Yes.
We have somewhere in here the workshops channel on the Linkerd community Slack. That is the place to go and join if you want to be able to ask questions, give us feedback, heckle, tell us how bad our jokes are, whatever. But yeah, we are talking today about Linkerd 2.17. Wow. Yeah, I can speak, really. I'm still in shock at how bad that joke was. Linkerd 2.17, we're going to be talking about federated services and Egress, which are two of the flagship features. They're not the only features in this release. They're just the only ones we're going to talk about right now. They're both pretty cool, and it'll be kind of fun to dig into them a little bit here. So the agenda for today, we're going to do an intro to federated services, followed by a demo of federated services. And then we're going to do an intro to Egress, followed by a demo of Egress. And what you will need to follow along, first off, here's the link to the source. There actually is, the source is there. You can go and take a look at it. I am using Buoyant Enterprise for Linkerd 2.17. You are encouraged to use Buoyant Enterprise for Linkerd 2.17 as well. If you want to stick with pure open source, Linkerd Edge 24.11.8 should be just fine for everything I'm showing here. This demo is a little bit weird. I'm using both K3D and kind of to just show off that the cluster that you're using doesn't really matter. I should probably also have added a link to Cattle Patrol because I'm using that one in here a little bit as well. And on that note, a quick message from our sponsors. I just mentioned I'm using Buoyant Enterprise for Linkerd. Go check it out. This is the enterprise-ready, hardened version of Linkerd. It can do a lot of cool stuff. It can do FIPS. It can do cool things with keeping traffic within a zone if you don't need it to go out of zone. Check it out. The QR code there will take you over to a place where you can get a free trial. I should also point out, if you're in a small organization, then you get to use it all for free anyway. So check it out. It's good stuff. The next Service Mesh Academy, January 16th, 2025. When did that happen? We're talking about OpenTelemetry and Linkerd. I'll be joined by Michele Mancioppi. And Michele, I apologize for mispronouncing your name horribly. He's from Dash Zero. They do a lot of stuff with OpenTelemetry. That should be kind of fun too. I'm actually looking forward to that one because that will require me to learn a lot of stuff about OpenTelemetry that I have avoided so far. So that should be fun.
He's very, very passionate. He came up to us at CubeCon, slammed his hand down, and he's like, "Why is no one doing OpenTelemetry right in the service mesh?" I'm like, "Let's fix that." And
we're kind of looking at Tom and I are looking at him and looking at each other, going, "Okay, dude, well, let's get on it."
Here's the next SMA right here.
Yeah. Federated services.
Yay.
Those of you who got an early invitation to this would have seen it talking about cluster agnostic services. Federated services have changed their name a few times. Still the same concept. Don't panic. We're going to go through and talk about what it is. I also like to apologize for the fact that we're using the word service, even though it's a horribly, horribly overloaded term in Kubernetes.
And
Linux, and really like everything else. But in this particular case, when I say service, I am talking about the Kubernetes resource that matches a DNS name and IP address to a bunch of pods. So if you've got some pods, each of your pods will have a distinct IP address, and the service is the resource that kind of links them all together, gives them a name that you can talk to, and incidentally gives them the cluster IP address that belongs to the service, which Linkerd relies on to do a bunch of the advanced routing stuff that Linkerd can do. So that is what I mean when I'm talking about a service. I should also point out that as we talk about this, you're going to hear about endpoints a lot. That is because endpoint is the proper Kubernetes term for those IP addresses that belong to pods that are all linked together by a service. There's also a Kubernetes resource called endpoints, plural, even if you're only talking about one instance of that resource. And there's a separate Kubernetes resource called endpoint slice, which I believe is singular, not plural, which is just one of the many fun things about Kubernetes. We can mention that a little bit later, but that distinction isn't terribly relevant right this second.
Yeah, these are the building blocks. So anytime you want to do something with services or load balancing, you really need to kind of play with these and understand what they are.
I should have hauled in the slide from my Everything is Awful talk at Kubernetes Contrib Summit to go and show how all of these things link together. That would honestly, that would be a good SMA in its own right, the Kubernetes building blocks. But yeah, so you're typically going to have a service which has a label which matches labels that have been applied on pods by a deployment or a replica set or a daemon, right? And all the labels have to match up so that the service can find all the pods that belong to the deployment. It's just a lovely, lovely thing. So here, though, we're talking about a service. The service has a set of endpoints that belong to that service. If you try to talk to, in this example, 10.99.0.1, the cluster IP of my service, Linkerd will catch that traffic, figure out which of those 10.64 addresses are relevant, and then it will route as appropriate. The question that Federated Services is asking is, what happens if these endpoints aren't all in the same cluster? This is one of those things where it's a very simple concept to talk about, and there is an enormous amount of very complex stuff going on under the scenes, or rather behind the scenes, under the hood, behind the scenes. I need more coffee, man. But simple to talk about, very complex to implement, which is okay because the point of Linkerd is to take the complex stuff and then arrange it so that you can use it without having to pay too much attention to the complexity. So this is almost a federated service. Federated services actually rely on the presence of services in all the other clusters. So a federated service isn't really taking a bunch of endpoints in other clusters and linking them together. It's taking a bunch of services in other clusters and linking them together. Those services will have their own endpoints. They could have more than one. They could have one. They could have zero. The point of the federated service logic is to just do the right thing no matter what the situation with endpoints in the remote clusters actually is. Another requirement here is that all of those services in your remote clusters must have the same name and they must live in the same namespace. This is a concept that we borrowed from SIG multi-cluster called namespace sameness. The idea here is that if you have a namespace foo in a bunch of clusters in a multi-cluster setup, and there's a service, my service, in your namespace foo, then namespace sameness is the assumption that if it has the same name for the service and the same name for the namespace, you're probably semantically talking about the same thing. So it's okay to go and refer to them in a federated service and just spread load across all of those clusters. And if you don't have that in some cases, don't panic. We'll come to that in a minute. So to do federated services, the first critical thing is that you have to set up the world like you're doing pod-to-pod multi-cluster, which means that a pod in this top cluster that I've shown in this diagram must be able to route by IP address directly to pods in all of the other clusters. If you're doing this in Docker on your local laptop, this is not a difficult thing to set up. If you're trying to do this in a cloud provider, it can range from annoying but not that difficult to impossible depending on your cloud provider. And Tom, I'm sure, can talk about lots and lots of war stories there. But right now, federated services require this pod-to-pod aspect. It won't work with gateway-based multi-cluster at this point. After you have those things set up, you go through and you put a label on each of your services that you want to participate in the federated service. And that label is now mirror.linkerd.io/federated with a value of member instead of mirror.linkerd.io/exported like you would use for normal multi-cluster stuff. When you do that, then that will cause the federated service to appear in all the clusters that are linked to your remote clusters. And by default, it will get a -federated suffix as opposed to a -cluster names suffix like you would see with normal pod-to-pod multi-cluster. There is a way to change that suffix. I confess that I have not played with that because mostly because it's kind of handy to just stick with the default in this case in a lot of situations, really.
Mm-hmm.
Yeah, this is one of those areas where a reason that you might tend to change that suffix is if you have an application that is really difficult to change how it's routing and you really want to match another name. Yeah, maybe you do something like that. In most cases, being able to distinguish between the federated service and a member of the federated service is really useful. It's not shown on this diagram, but this works just fine if this top cluster also has an instance of my service in its relevant namespace. Anything you wanted to add about that, Tom?
No, you're right. I've played with this with our other teammate Phil, and we've done a 3 cluster setup with 3 instances of the same application, and works just fine. Like, master it with the federated. If you want to play with the more advanced stuff, once you get the basics down, then go ahead and feel free to change it. But
yep.
Before, people used to do this with front-ending multi-cluster services with like HTTP routes, and this collapses everything and makes it much more straightforward. The other thing that we've done and that we continue to do with multi-cluster is to make the day-to-day operations more simple. Like, we're going to eliminate the need to relink clusters every time you upgrade and things like that. So multi-cluster itself is getting better. Federated services is one part of that, but it's going to require a flat network. So when you go look at the multi-cluster communication docs, make sure that you're focusing on that you need that flat network. And so, for example, if you're running in AWS, you would need to have everything in one VPC. So,
yep. And there's also a very important difference between federated services and fronting multi-cluster services with HTTP route, which we will show in the demo.
Yep.
So everybody hold on for that. Okay. Demo time for, federated services anyway. Let's talk briefly about the demo architecture. As usual, we are using the world famous Faces demo, which often looks like this. The way Faces is normally set up is you have a cluster, you have a web browser running the Faces GUI outside the cluster. The GUI talks to a workload called Face. Face talks to a workload called Smiley and to a workload called Color. The Smiley workload is supposed to return this grinning smiley. The Color workload returns this blue color. The Face workload composites the two together and hands them back to the GUI, and you get a grid of, hopefully, grinning faces on blue backgrounds. For today's demo, we are going to cheat, actually quite a bit. The first way we're going to cheat is that we are not going to run Smiley and Color in the cluster with the Face workload at all. We're actually going to run 3 distinct clusters, each of which are running the Smiley workload. The Face workload and the GUI, the workload that actually serves the HTML, those will be running in their own cluster. And just for the fun of it, this is a K3D cluster. These are kind clusters. And I lied, the Color workload isn't running in a cluster at all. The Color workload is just running in a Docker container that's attached to a network. And although it's not shown on this slide, it's a different Docker network between the Face cluster and the Smiley clusters, and the Face cluster and the Color container. And the Smiley containers don't even have access to that network at all.
Did you involve mesh expansion with this?
I could, but I didn't.
Okay, this is
just an Egress demo.
Gotcha. Yeah. Gotcha. Cool.
This is just Egress, dude. Slow down.
Okay.
But it would be kind of fun to go ahead and throw mesh expansion in here as well. I bet you we could figure out a way to do that. Another way in which we're cheating is that we're not really running an Ingress controller. We're running the Face GUI in a mode where it kind of pretends to be an Ingress controller. That's because the setup was complicated enough and I didn't want to throw yet another moving part in there. But the reason to have anything there on the edge really is so that we can stick Linkerd everywhere and have Linkerd do the things that you want when you start talking to these various services. I'd also like to point out, if you look carefully, you'll realize there is no Linky the Lobster here. And that's because this is egress traffic. Color is not part of our mesh. It's hanging out outside someplace. The fact that it happens to be still running on my laptop is irrelevant. I could have run it out in, I don't know, out in somebody's cloud, and the demo would work just the same. I didn't do that because I wanted the demo to be self-contained, and because if I put it out in somebody's cloud, I would have had to screw around with DNS. Tom has heard me say on many an occasion, any day I have to think about DNS is not a good day.
Yeah.
So
it's always DNS.
Yeah. Yeah. So that's the demo architecture. We're going to have 4 clusters running, 1 Docker container, and we're going to hook it all together, and it's just going to work, and it's going to be great. Right? Right. So, oh yeah, you can tell where I stole this slide from, huh? Oops. All right. Let's get to the demo of this. The setup for this is complex. So I am not actually going to show you the cluster setup unless I screwed something up. Assuming that we have time, then we can come back to that after, and I will show you the script that sets it all up. It's ugly. It's like 400 lines of bash because unfortunately setting up 4 different clusters and linking them all together with a Docker and all this stuff, it's fairly complex. There's just not a really, really great, clean way to do this. I'm kind of, for the practical multi-cluster SMA, I did a bunch of Python that did this, and I don't think that really made it easier to understand. So I'm still looking for a better way. But in our K3D face context, that's a K3D cluster, we have the face and faces GUI workloads running, and we have services for the same things. You'll note that one of them is a load balancer service, so it actually has an external IP address. I should also point out, I am using OrbStack rather than Docker for Mac. One reason I'm doing this is so that external IP works from the rest of my host, since I'm running the browsers on my Mac, not in Docker on my Mac. And another reason I'm running it is so I don't have to think about the DNS. We'll mention that a little bit later. In kind Smiley 1, we have a single Smiley workload with its service, which you'll note is not a load balancer service. And in kind Smiley 2 and in kind Smiley 3, we have exactly the same thing. Right. Now, I have also told the face workload in the K3D face cluster to talk directly to the service called Smiley-Federated instead of its normal service called Smiley, because again, that simplifies things a little bit. Right now, if you scroll back a little bit though, you will note there is no Smiley-Federated service in my faces namespace in K3D face. So if I flip to the browser right now, nothing good will happen. Specifically, we see nothing good happening. We got cursing faces, we got gray backgrounds. That tells us that the GUI can talk to the face workload and the face workload can't talk to anything else, which is what we expected. So that's okay. So if we come back, the first thing we're going to do is, this is the federated services part of the demo. So let's go ahead and set up Smiley to be a federated service. And we have to start by installing Linkerd multi-cluster everywhere. This is the usual multi-cluster install. I'm explicitly telling it I'm not doing gateway-based multi-cluster, so don't bother with any gateways. I am running the Linkerd command in the K3D face context, and I'm running the kube control apply in the K3D face context. So Linkerd is going to generate a bunch of YAML for me that belongs in K3D face, and then we're going to put it in K3D face. And then we will repeat exactly the same thing for Smiley 1 and for Smiley 2. I'm just going to go ahead and rush these commands a little bit. And for Smiley 3. And again, in all cases, we've got the same context for the Linkerd command and the kube control apply command. After we do that, we can go ahead and run multi-cluster check just to make sure that things are running. Another way I cheated, which Tom, you might find entertaining, is all of these clusters are connected to the same local Docker registry, which I preloaded with all the images.
Yep.
So I don't have to wait for it to pull images all the time.
No, that's smart.
It makes a huge difference. So after that, we're going to link from K3D face to the Smiley clusters. I'm not linking the other direction because I don't need to. I'm not putting links from one Smiley cluster to another. I'm just linking from K3D face into kind Smiley 1, kind Smiley 2, and kind Smiley 3, which will permit me to have services in the Smiley clusters appear as a federated service in the face cluster. Here, we do not use the same context everywhere. Our Linkerd command, the multi-cluster link command, we're going to run it in the Smiley 1 context, but we're going to apply it in the face context. What this is doing is this is going to generate me a link CRD that talks about kind Smiley 1, and then we're going to apply it in the face cluster because that's where we need it. So we'll do that for kind Smiley 1. This is the same, exactly the same thing for Smiley 2.
It's like 90% of setting up multi-cluster for me is to make sure I have the right context in the right place.
You're so not kidding. Also notice that gateway equals false again. Right?
Yep.
Yeah. Pod to pod, not doing gateways here. And then we're going to do exactly the same thing in Smiley 3. And to Tom's point there, I totally didn't get this wrong the first 2 or 3 times. Definitely not. Never. Yeah. All right. So we're going to run multi-cluster check again. And this bit here, this is me discovering a bug in multi-cluster check. I set up these clusters using an external CA like you would if you're doing Cert Manager or any other automatic rotation. So what I did was, rather than telling Linkerd, hey, here's the actual PEM for your trust anchor and things like that, I just told it, hey, the secret's already there. Just go ahead and use the secret that's already in the cluster and do the right thing. And it turns out that multi-cluster check gets a little confused by that. So we're going to have to fix that. But I promise you, these are all using the same trust anchor, and it's really okay. So once the links are up, we can go mark the Smiley service in each of the clusters for federation. And when we do that, this will cause the Smiley federated service to appear in the face cluster and be linked all to our other clusters. So I'm going to do that for Smiley 1, Smiley 2, and Smiley 3. Labeling things isn't really complicated. But we will see that there is the Smiley federated service present now. Always a good sign. The mirroring bit did its thing. And if we run Linkerd diagnostics endpoints, then we can see the endpoints that are actually behind it. Interesting thing, if you try to use kube control get endpoints or kube control get endpoint slices, you're not going to see anything because the Linkerd control plane is the one that's managing everything there. So, but Linkerd diagnostics endpoints is your friend. And if we flip over to the browser now, we see smiley faces. Yay! So at least part of this worked. We don't actually know where those smiley faces are coming from, is worth pointing out, because they all look the same. So we're going to cheat here a little bit, and we're going to change which smiley is being returned in each of our clusters. So right now, Smiley 1, Smiley 2, and Smiley 3 are all returning the grinning face smiley. I'm now going to make Smiley 2 return the hard eyes smiley, and then I'll make Smiley 3 return a smiley with rolling eyes. Setting the environment variable requires a restart, which is why this takes a second, but there you go. So now we can see a mix. We can see that we're really getting things across all of our clusters here.
You added some tweens to the mix.
Yeah, basically. One of the other fascinating things, this is actually, to me, this is the fascinating thing about federated services, which is that they act like services, right? And so if I scale Smiley 1 down to 0, I'm not going to get any errors. I'm just going to see my grinning smileys go away. Now all I have is rolling-eyed smileys and hard-eyed smileys. This is the difference, maybe not the difference, but probably the most important difference between federated services and using an HTTP route to front mirrored services the old way, is that the way HTTP route is defined, if you have an HTTP route fronting a bunch of mirrored services and your endpoints for one of your mirrors go away, HTTP route requires us to return errors when we try to talk to that endpoint, rather than doing this business where we just go, hey, that endpoint's gone, we're not going to talk to it. And the reason for that is that anything you can do to HTTP route to make this better in the federated case makes it worse in the progressive delivery case. So it's a tough situation, really. If we look over here in the endpoints, we will see that the smiley1 endpoint has simply vanished. We only see two. Little secret, 10.55.2 is the smiley2 cluster. 10.55.3 is the smiley3 cluster. We don't see any with 10.55.1 because I just removed it, right? But if I scale that smiley1's smiley workload back to 2 endpoints in this case, because 2 replicas, because why not? Then first I'll start seeing grinning smileys again, although it'll take a few seconds because the thing has to start running. There we go. There's some grinning smileys. The astute observer will note that the ratio of grinning smileys to other smileys has changed because there are now 50% of the endpoints are grinning smileys, not 33%. And if I go and rerun this endpoints command here, then endpoints takes a few seconds now to make sure it's everything. We now see that there are 2 in 10.55.1. So we scaled it back up. The endpoints just magically appeared in our federated service. Of course, in the real world, unhappy workloads are rarely polite enough to just vanish. They will often start returning errors. I can do this by changing all of these to fail 30% of the time. You can already see some cursing faces showing up here. That would be a case where we tried to talk something and hit that error fraction. So if I do this, then about a third of our requests are going to fail. If we use the shiny new Linkerd viz stat outbound command, then if we leave this running for a few seconds, we're going to see this drop. The success rate will come down to 70% if we give it long enough, which I'm probably not. But you can see it falling, and so, okay. I actually really like this command, right?
Oh, I love it. These are beautiful.
Hey, we're coming from face, and we're going to talk to this thing, and look, everything is going to the smiley federated endpoint. Isn't that cool? So the natural way that you would want to deal with these kinds of failures in Linkerd is with retries. And since federated services are services, we get to do that just by annotating our service. In this case, we're going to annotate it and say, hey, I want you to retry on any 5xx status. You can have a limit of 3 retries, go to it. And the moment I do this, the cursing faces just pretty much go away. Even given that none of those endpoints are the same cluster. If we watch this for a little bit, we will see this success rate go up. We should see this RPS go up. We should not really see this success rate go up. And again, I'm not really going to give this long enough to get all the way to 100%, but it will get very close to 100%. It won't quite get to 100% because I told it was limited to 3 retries. And it is possible, not necessarily likely, but it's possible to ship a request that hits smiley1, smiley2, smiley3, and gets a failure on all 3 of them and then just gives up. So we never quite get to 100%. And you can see it's trending in the right direction. Again, I'm not going to actually wait long enough to see it go all the way to 100. Okay. Any questions so far? Anything you think I've missed?
So what you were looking at there was like an inbound error, right? So we did the same thing in our KubeCon talk about topology-aware routing, inbound versus outbound, right? Where technology like topology-aware routing can deal with the failure of endpoints, but it doesn't know anything about status codes and failures that are happening within the application. And that's where service mesh helps you.
Really, topology-aware routing can understand things like endpoints going away really well. It has a much harder time with an endpoint that's still there, but it's giving you a layer 7 error.
Yeah. No, it just sees traffic is still there. We're all good, right?
Yeah. Yeah, but one of the cool things with Linkerd is that we get to see the layer 7 statuses, so we can go and retry, and we can go and do other cool things. Another thing we can do is auth. And here, what I'm really going to be showing you is a bit of a gotcha. The federated services do act like services, but you need to remember that, at least for the moment, you need to remember that they are not in the same cluster when you're trying to do auth. So let me show off. Here's a setup where we can create a service account named Face in the Faces namespace. And then we can define a server in the Faces namespace that says, hey, pick all our smiley pods on the HTTP port. And then we can say with this auth policy, wow, I did these in the wrong order. If you're trying to talk to our smiley HTTP server, you must have an authentication to match this face authn, which requires the service account identity that we just created. I realize that this is probably not the best introduction to Linkerd authorization policy ever, but trust me, this is a way that should be saying, hey, don't allow anybody who's not using the face service account to talk to our smiley workload. And if I apply that right now, then because our face workload is using the default service account, this is actually the Linkerd identity command, by the way, huge win. What's going on here is we're saying, get me the identity within K3D face of everything that matches the service equals face label in the faces namespace. And the only thing that's going to match that label is, you guessed it, the the face workloads right now. So if I apply that policy, we should no longer be able to fetch smileys. And in the event, I apply the service account, and then I apply the policy, and absolutely nothing happens. Yay. The reason for this is that auth happens at the inbound proxy with Linkerd. What's happening right here is my face workload has a proxy. When face makes a request to Smiley, the face application container talks to the proxy in the face pod, which then makes a request over to the proxy for the Smiley workload. In this case, that's making a connection to a proxy in a different cluster. And that proxy that it's connected to that belongs to the Smiley workload, that's the one that has to make the authorization decision. So we need to put the auth in the clusters where the inbound proxies actually live. Again, at least for now. It'd be cool to see some further things going on here, but this is the way you got to do it at the moment. So in Smiley 1 and Smiley 2 and Smiley 3, and you can see that with each one of those, more and more of these things turned into cursing faces.
I think you didn't get 3 there. I think you had two copies of 2 there. In the context.
I think you're right. That's really weird.
You don't have to become an expert at auth policies. With Buoyant Enterprise for Linkerd, we do have a Linkerd policy generate command, which will spit out a nice manifest. So if you've got an application with that's pushing traffic the way it should, you can see what policies would be generated, and then you can edit those, apply those. So it's a nice feature, because this is kind of a lot to get your head around, like initially. But if you think about it kind of like RBAC, you got 3 things, you're tying them all together, they got relationships, and you can start to kind of figure it out. And again, use that Linkerd policy generate command to see what like an example would be, based on your app.
Yep. The funny expression on my face actually is because I'm looking at this going, so how was the auth policy applying to everybody if I got 2 of my 3 clusters?
Yeah. Whoops,
and I'm gonna have to go and look into that a little bit more. But if I update the service account, then we're back to normal.
Woo-hoo. Love it. I know. I had my fingers crossed down here.
So however I broke it, I didn't break it that badly.
Magic.
All right. So there you go. There's the whirlwind bit for federated services. And now we're going to go back and look at egress.
Huge feature that customers have been asking for.
Yeah. So what's really funny now also is I'm sitting here going, I just know I'm going to go back to the demo and I'm going to find that there's some other thing about federated services that I
got my eye on you.
You know what? Let's just find out, shall we? Ooh, there is. I don't know if anybody noticed this, but we didn't create the face service account in any of the Smiley clusters. Did you notice that, Tom?
I did.
Yeah, we only created the face service account in the K3D face cluster, but it works to refer to it by name in the other clusters because Linkerd multi-cluster is keeping all the clients honest about who their identity is, and because Linkerd multi-cluster also requires that you have a trust relationship between all of your clusters. So an incoming connection that lands in Smiley 1 or whatever gets to rely on the fact that the name is okay, and it can just go ahead and work with that.
Yeah, and pod to pod, it's all proxies
nice.
talking to proxies. So it's like it's in one big cluster. You have one common data plane, right? So it gets around a lot of the issues folks used to have with gateway-based, where you're putting behind something. It's not that
gateway-based. Yeah, auth in the gateway-based world is surreal.
Different.
Yeah. Okay, so now let's head back over here and talk about egress. A little bit of background. Egress is distinct from ingress. The ingress problem starts off with users trying to use things in the cluster from outside the cluster. And this is not a thing that you're allowed to do. This is part of what clusters are all about, is preventing this from happening without control applied to it. So we need something sitting out here at the edge of the cluster that can mediate access from outside the cluster to inside the cluster. And that thing became called an ingress controller. There's also an ingress resource. Don't worry about the ingress resource. We're not going to talk about the ingress resource. It's not relevant for this. Now, the egress problem is kind of the opposite, where you have workloads that will sometimes need to talk outside the cluster. Generally, this is allowed, which is in fact the egress problem, because if you have workloads that are talking to good things outside the cluster, fine. But if you have workloads that are talking to evildoers outside the cluster, that is a lot less fine, and you need to do something about that. Something could mean maybe you just log it somewhere, or it could mean that you want to actually block the traffic, but you have to start by knowing what's happening so that you can do something about it. And this is the core of egress. You want to, at minimum, know what's going on, and ideally, you want to have some ability to affect what's going on. Now, another thing you might want to do is to force your traffic through an egress controller, which kind of acts like an ingress controller, but it is mediating access going outwards, looking at things like, I don't know, user auth or whatever. The egress controller idea is the most flexible egress option, but it is also the most complex egress option.
A lot of customers had an issue, again, where they were using ingress controllers or other mechanisms to get around. You wanted to block workload A from talking to workload C in a namespace, right? And they could always do that end around, and this puts a squash on that too.
There's a long history of doing what we call hairpin routing through an ingress controller. And don't do that. It's not, I mean, it works. It just tends to add load to your ingress controller, slow things down, possibly screw you up. Better to use a service mesh if you're, yeah, exactly. Adding load to your ingress controller, meaning adds cost.
Loads to your wallet.
Yeah. Especially if you're doing the thing that we've seen some people do where they hairpin to the external address of the ingress controller. That becomes both egress and ingress traffic from your cloud provider's point of view.
Double down.
Service meshes are better at that. Egress controllers, incidentally, there are not a lot of purpose-built egress controllers out there right now. People tend to just sort of abuse ingress controllers to be egress controllers, which is an interesting, it's a business opportunity for somebody probably. Now, moving back to a little bit of background to set the stage for how Linkerd solves egress. This thing you might have heard of recently, Gateway API. Gateway API was invented to be a way of dealing with the ingress problem that was more portable than the old ingress resource. So you would specifically stick a gateway controller out there, which is configured using Gateway API resources. And the cool thing about Gateway API is that the core of Gateway API is pretty much independent of the infrastructure that you use it on. So you can mostly learn about it once and then run it anywhere in kind of much the same way that If you learn how deployment works, then deployments work no matter what sort of Kubernetes cluster you're running. Gateway API also defines resources, like I said, to configure the various things. There's a gateway resource that configures the gateway controller and talks about what kind of controller it is and what it should be able to do. And then you have route resources that talk about how the gateway controller should route traffic to workloads. Your basic route resources are fairly simple. So like here's an HTTP route resource that says any HTTP traffic arriving at the Faces gateway with a hostname that matches smiley.example.com should get routed to the Smiley workload on port 80. Not very complex. There's a lot more complexity that you could do here. There's also a thing called a gRPC route that is very similar to an HTTP route, but has some things that are more tailored to gRPC. So, for example, this one still has a hostname match, but it also has this match where we can talk about matching the gRPC service and method. And again, we could spend a lot of time talking about all the complexities of how you can do route matching, but we're not going to do that right now. The most important thing about this is realizing that all of those routing concepts pretty much work if you're talking about traffic within a mesh as well, traffic within a cluster. So these same concepts where you've got the gateway routing, those pretty much work in exactly the same way with exactly the same resources if you're talking about traffic between workloads in your cluster and not involving the gateway at all. So with that in mind, Gateway API started figuring out how to adapt Gateway API to the mesh. The biggest difference here is not what the request looks like, it's where the request arrives. And you can end up doing things like this, since the difference is that your request is going to arrive at a service instead of arriving at a gateway. We change the parent ref to talk about a service. And then the rest of it's pretty much the same. Although there are going to be things that a gateway controller can do that a mesh controller probably will not be able to do. Like, the example I keep coming back to is it's fairly unlikely that you're going to be doing cores in a service mesh. The concept doesn't necessarily make a lot of sense, whereas it does make a lot of sense for a gateway controller. So ultimately, the thing that's really interesting about this is that the route resources in Gateway API don't just talk about how you route traffic, they also end up defining classes of traffic. That's a really interesting point. The parent ref actually dictates what kind of traffic the thing is. If you have a parent ref of a gateway, you are by definition talking about ingress traffic. People who are Gateway API purists at this point usually point out things like, oh, but you don't have to have the gateway controller right at the edge of the cluster. It could be an internal thing, but you're still talking about ingress traffic because by definition, gateways are defining a point at which traffic can cross an administrative boundary. The cluster is the most common administrative boundary, but at any point, if you're talking about traffic coming into a new admin boundary, that is ingress traffic. For mesh traffic, the parent request is required to be a service, at least at present. There's an experimental thing. I think it's still experimental where you can also talk about a multi-cluster service import. Haven't seen that get used a lot yet. So this kind of raises a fun question of, if we want to talk about egress traffic, then what should we use for the parent? We can't use a gateway because the gateway is talking about specific rendezvous points associated with the cluster, and that is not egress leaving the cluster. We also can't use a service. It's true that an external name service exists, but you can't exactly cover the entire internet with external name services. That just doesn't make any sense. So we need a new thing. And the new thing we came up with is called Egress Network, which is a Linkerd CRD, not a Gateway API CRD. Egress Network defines the class of traffic that is leaving the mesh for a destination matching a particular CIDR. That phrase, leaving the mesh, is very, very important here. When you're talking about Linkerd multi-cluster, traffic between the clusters still in the same mesh, that is not egress traffic. Likewise, if you're using mesh expansion, traffic to external workloads, also not egress traffic because it's still within your mesh. Egress networks are not very complex. Here's one that blocks all of the egress traffic, full stop. It doesn't include a CIDR. It does not include a specific CIDR, so that means all the CIDRs that are leaving your cluster. Note that the API group is in policy.linkerd.io. It is not in gateway.networking.kates.io. This is important in a couple of different ways. Here's one that only blocks traffic to a specific network. Bonus points for anybody who can point out what's wrong with that CIDR specification. The other thing to notice here is that these are in a specific namespace, Linkerd Egress. That's the special global egress namespace. You can configure the name, but these are namespaced resources. So you can put egress networks in a particular namespace to say egress traffic from this namespace is subject to this kind of policy stuff. If you put it in the Linkerd egress namespace, it will apply to all traffic from any namespace that doesn't have its own egress networks defined. The reason for this is that if you don't have a default catch-all, you have to create a lot of egress networks all over your cluster, and that's going to get really irritating. So having the default makes really a lot of sense. Now, you'll also note that those had a traffic policy of deny in there. And basically, what we do here is we get to use the egress network as a parent ref for a route that tells us what kind of egress traffic is allowed. So if you have an egress network where you have set the traffic policy to deny, you must define routes that tell which egress traffic is allowed to leave. So here, for example, is one that is just saying that any HTTP traffic on port 80 to a hostname of smiley.example.com is allowed. You must specify the group in the parent ref here, because if you don't, it will default to gateway.networking.kates.io. Don't do that. You must specify a port, because it's not really meaningful to talk about egress traffic being allowed to every port in the world. And the usual matches get supported here. If you want to, you can also put a backend ref on this, which will force the traffic through an egress controller. I'm not going to demonstrate that in this particular demo, but in the KubeCon talk that I stole these slides from, which I did, we do demonstrate doing an egress thing. I'll find the link to that. And actually, I should have the link to that close to hand. But towards the end, we'll put the link to that up in case anybody wants to check that out as well. All right. There was a note that I just kind of scrolled past of the egress network works for HTTP routes, gRPC routes, TCP routes, and TLS routes. Do be careful if you're using an egress controller. Make sure that you actually allow egress traffic from your egress controller, or weird bad things will happen. Again, not that any of us would have any personal experience with that. You understand. All right. Back to the demo. Unless, Tom, did you have anything else you wanted to add there?
No, one thing with Gateway API, this is very new stuff. They're building this as they're playing as they're flying it. So you have to pay careful attention, especially if you're going to start mixing multiple things that leverage Gateway API. Make sure, that you're aware of the CRDs you have installed and that you're using the right ones. And, it's one of those things that as this gets more maturity, it's going to wash out. But it is a sticking point. Don't give up easy. Realize that, you may need to use a certain version of like HTTP route or some of these other CRDs to satisfy everybody's needs, but there's solutions to it.
Yeah, the CRD APIs are new enough that there's not a really formal way of managing CRDs that are shared by multiple projects.
Yep.
And so you end up in this world where, Linkerd can go and install Gateway API CRDs for you, but it will install a different version than a Gateway controller may install for you. So if you are mixing projects, my recommendation would be to install the Gateway API CRDs by hand and then tell all the projects, don't touch them.
Yep.
That way, that's your way of getting the best control over everything.
Yep.
So we have Smiley federated. We're getting smiley faces. That's great. we're now going to run in Docker, no Kubernetes. We're just going to run the color workload in Docker. And lo and behold, we have nice, shiny blue backgrounds. How cool is that? You'll also notice that I told it -- network egress because that's the one that I want it to appear on. Another thing that is kind of relevant here is that, and I apologize, by the way, for the way this window is shifting as I turn off the browser. Screwed something up. Like I said, I'm running OrbStack. And one of the nice things that OrbStack does is that it arranges for the DNS to do the right thing when I run workloads in Docker. If you are not using OrbStack, you may need to go tweak your DNS to get this part of the demo to work correctly. One of the many reasons why I do recommend using OrbStack if you're trying to do Docker things on a Mac. Okay. Now, at this point, we do have egress traffic happening. We just don't have a lot of visibility into it yet. The Linkerd. Wow, am I still here?
We hear you.
Okay. This is how you know we're doing it live, folks.
No editing.
Yeah.
We'll get Flynn back.
Awesome. You know, candidly, you might not actually get me back for video for a second. Let's try this again. Alrighty. Well, we're just gonna. I got one more thing I can try before I just go on and
let's do a radio style broadcast.
Yeah, exactly. Which, you know, would be okay. It's not the worst thing in the world.
We all love the olden days of radio.
Yeah. Wow, that's awesome. It just told me it connected to the right camera, and it's not showing me anything. This makes me very sad. All right. Let's try this bit. All right. Well, I guess we're just going to do this radio style.
Let's go.
Let's go. Okay, so we have egress traffic happening. We don't have a lot that we can see about it yet. So we're going to go through and run the proxy metrics command. Proxy metrics is kind of a funky command. It goes through, connects to a given Linkerd proxy, and pulls the same metrics out of it that something like Prometheus would normally be scraping. You'll appreciate that this is a very verbose set of data. So we are going to filter it down. We're only going to look for metrics that end in route request statuses total, which is a metric that I happen to know is useful. And we're also going to hunt for egress in there to see if we can find some egress traffic. And if we do that, we get a truly horrible thing. I'd like to point your attention to this number 1543, which is, this is a count.
Yep.
Specifically, this is a gauge if you want to get into Prometheus terminology. So the value there is 1543. I'm going to throw this sed on the end so that every curly brace and comma will get a new line stuck after it. And if we do that, it's at least easier to read. A couple of things that are interesting. First off, 1741 is greater than 1543. So we can see that new events are actually coming in and going along, right? The other thing we can see is that, oh, hey, look, this is traffic to a host name called color. That's a good sign. And we can see that it is succeeding. And it mentions a route called egress fallback, which implies that Linkerd recognizes that there's egress traffic happening here, but it doesn't really know a lot of other stuff about it. So far, so good. You'll also note that it says that this is an HTTP route, even though we know that color is really gRPC. The thing that's going on here is that Linkerd can tell what is HTTP and what is not HTTP pretty effectively, but distinguishing a random HTTP2 stream from a gRPC stream is considerably more difficult. So it doesn't bother. So if we set up an egress network and we explicitly tell it to allow all the egress traffic, then this won't stop anything from happening, but it will give us a little bit more information about what's going on. which gets us into that observability thing. So here we go. I'm going to create the Linkerd egress namespace, and then I'm going to add an egress network to it. This is almost identical to the one that I showed earlier in the slides. I'm setting the traffic policy to allow here instead of deny, to explicitly say, I don't want you to block any traffic. Just let it happen. If I do that, then I will have a new entry in the metrics output. I'm going to skip ahead there. And so this is the first one that's talking about the egress fallback. Its count is now 2524. And now there's a new one. Color, HTTP status 200, but it is going through the route named HTTP egress allow, and it has a parent of all egress. All egress is the egress network I just created. That HTTP egress allow is a default. That's basically saying, oh, this is HTTP traffic. It matched an egress network with a traffic policy of allow. So I'm allowing it because that's what I do. If we run this command again, then we will be able to see that 434 here for our HTTP egress allow is quite a bit larger than 51. But in both cases, this 2524 stayed the same. So we know that nothing is going through the default route anymore. It's all going through our custom thing. This is horrible to read. So instead, I am going to fire up a Python script that parses things a little bit more gracefully for us. The real proper production ready way to do this would of course be to go and build out a Grafana dashboard and a whole metrics pipeline and do all this stuff. I'm doing this with Python for two reasons. The first one is I want to show the text that goes after that via word. I want to show which rules are allowing particular traffic while I still want to break it down to be requests per second. The other thing is that I kind of wanted to demonstrate that you don't have to go through and build crazy complex Grafana stuff. You literally can interact with metrics just by running stuff with text, which is kind of cool.
Yeah. Now this is cool too. So if you think about this, when you're leveraging metrics, is that you could define different metrics rules so that you can monitor traffic more granularly, or you could ignore certain types of traffic if you wanted to like suss it out of your metrics as well, like folks do with HTTP routes.
And in fact, we encourage you to do so.
Yep.
So next up, as soon as you have control, you are kind of obligated to use it to break things, right? Isn't that the way that works?
Yeah.
So we're going to switch the traffic policy here to deny. That's the only change we're making, is we're just taking our egress network and telling it, done with that, deny everything. And the moment we do that, then we have gray backgrounds again. All of our blue has gone away because it is no longer allowed.
Very handy. You can shut things off. You're having a problem, you notice an attack, shut it all down.
Which is a good thing.
Yeah.
I'm getting really distracted by the fact that my window here has gotten so totally broken in terms of its scaling. So if y'all will indulge me for just a moment, I'm going to fix that so that you can read the stuff that you're supposed to be able to read. All right.
Very nice.
I'm having one of those moments where you go, it worked fine in rehearsal. What changed? Anyway, yeah. So all of our egress traffic is being blocked. We immediately see HTTP color 403 because, again, Linkerd still thinks that this is HTTP traffic. We also see via HTTP egress deny because we haven't given anything special. It's just doing its usual default kill it all because the traffic policy is deny. Obviously, that's not very interesting if we want our demo to work. So to get it to work, we have to go and apply a gRPC route because face talks to color via gRPC. So what we do here is we put in a parent ref that is our egress network. We specify the port 8000 because that's the port that's involved. And for the fun of it, we're going to tell it a match of anything using the color service, which is the one that we're using, is okay. And if we apply this, we're back to blue backgrounds. And if you look down at this window,
there we go.
Color OK via allow color. Allow color is the name of that gRPC route we just looked at, right? So we get to see not just that a thing was okay, we also get to see what was permitting it to be okay, which is important. And if we keep watching this, then the 403s have actually already scrolled off. But slowly over time, these will drop down. I'm not really going to sit there and watch all of it or wait for all of it to do that.
Just got to let them flush out of the queue.
Yep. That's the way metrics work. Now, we can also use routes to talk about traffic that lets us get more specific. So the Faces demo itself actually has two different, the gRPC has two different methods. The center method gets used for these 4 cells in the center, and the edge method gets used for these cells out on the edges. So we can use that if I modify my allow color gRPC route and throw in a match that includes method edge, then now this will only work for the edge routes and it won't work for the center, or sorry, the edge cells. So it won't work for the center. So once we apply that, then we will start seeing gray backgrounds in the center cells as they refresh. And we start seeing permission denieds as well via gRPC egress deny, because now we know it's gRPC traffic. There is a matching gRPC route for some of this. And so we know that we can deny it because it doesn't match the specific route that we have in place there. And also, just for the fun of it, in the GUI, there's a little box where you can type. Oops. Hang on another second while I get that back up on the screen. In the GUI, there's a little box where you can type that lets you set a username. And we can use that because it's passed along as a header. So we can say, oh, we're only going to allow center access if it's the center user. It's this box here. Actually, let me tweak that. Now the user is unknown. Nothing changed because I haven't applied that rule yet. But if I come back over here, oh, you know, one other thing that I should point out. This is not the allow color route anymore. This is a separate route. So we're going to end up with one route that permits traffic going to the edges and a separate route that only permits some users for traffic for the center. And that's important here because we want to allow those two different combinations of things. So if I apply that, then nothing will happen for the moment. But if I come back over to the browser and then I put in a username of center, then that gives me nice blue things in the center. If I put in anything else, like center lowercase, then I'm back to gray. Or if I put my name in, I'm back to gray. Only that one user is allowed to do that. I should also point out that, yes, in any sort of vaguely real-world thing, you would have to authenticate as the user instead of just typing a name. But the point of this is not showing off about how to do GUI authentication. The point of this is to talk about how gRPC routes can permit egress or not. So there we have it. There's the Whirlwind Federated Services and Egress tour. There's a lot more to this. But as always, the next thing that we need to talk about are the gotchas, because there are a few. One of them apparently is my camera, for that matter.
There's no slides for that one.
Yeah, yeah.
You have time.
Let's try disabling and re-enabling the camera again. No, my camera has just lost its tiny little mind, folks. That's awesome.
I was considering using one of my fancy cameras, but this is the same thing that happens with them, so I stuck with my cheap $40 pandemic camera.
This camera's been working fine, man. It's the way it goes. Anyway, okay, first off, you'll note that my egress network, I did not specify a CIDR for that egress network. If you don't specify CIDR, it specifically defaults to the entire network space except for what you gave in the cluster networks parameter when you set up Linkerd. And the reason for this is that cluster networks is defined to mean these are all the CIDR blocks that belong to the cluster, and then everything else is outside the cluster. If you don't specify cluster networks, the default is all the RFC 1918 networks. So if you are trying to do egress and you're trying to do IPv4, which we were doing here, it's basically guaranteed that you're going to have to override cluster networks to get good results. Because if you don't, probably, since Kubernetes really, really likes to use RFC 1918, if you don't override anything, then you may very well end up in a place where your egress traffic actually falls inside cluster networks, even when you don't expect it to. I also ran into this one when I was setting this demo up at one point, because I typoed a net mask and accidentally did 172.17/16 instead of 172.17.0/24. That took a minute to figure out. The recommendation here is set CIDR cluster networks to the union of your pod CIDR, service CIDR, and node CIDR for all of the clusters in your multi-cluster. Depending on your specific application, you may very well be able to reduce some of those. Like you might not need the node CIDRs in there, for example. Think about it. Think about your application, but recognize that you may very well need to have it be the union for all the clusters you're using rather than just one cluster. Next up, if you have a route with an egress network, you have to give it a port. You cannot say, hey, any traffic on any port that happens to match this host name or whatever. You must give it a port in that route. Also, if you take advantage of the fact that egress networks are namespaced and you put an egress network in a namespace, it will completely replace any global default egress networks. They don't compose. The ones in the namespace just override the default namespace. Much easier to reason about, but arguably not necessarily something that's going to come immediately to mind. If you try to use TCP route and TLS route, Gateway API requires that they have at least one backend ref. The reason for this is that if you're using HTTP route or gRPC route, then it's meaningful to talk in some ways about a default backend, but for TCP route and TLS route, it's less meaningful, so you must include a backend ref. This is a little weird because for egress traffic, you don't have anything good, and the way we dealt with this is you may use the egress network as the backend ref as well as the parent ref. Obviously, if you want an egress controller, you would use that as your backend ref. But if you don't want to use an egress controller, use the egress network. If you do that, you must use the same egress network as you did for your parent. Just because it makes it that much more clear. And if you try to do something with a different egress network for those two, I don't know what that would even mean, right? Finally, federated services and egress do not compose. This is something where, actually not finally, there's one more after this, but they don't compose because federated services are services and egress by definition is not a service. So this really makes sense. It doesn't make a lot of sense to talk about including some egress whole CIDR block in a service, but it's still a thing that I wanted to put in here because in a lot of cases, when you talk about egress traffic, you will be talking about a single IP address. And it might seem natural to go, oh, yeah, let me try to use a federated service to span a bunch of these things. Can't do that. If you want to do that, you probably want to be thinking about mesh expansion and not federated services. Or I guess I should say mesh expansion. Honestly, mesh expansion and then a service federated over a bunch of external workloads is a fun thing to think about. I'm going to have to try that next.
Yeah, because you're putting those into the data plane, and now you
And
have
they,
control over
yeah, it's you can't see the funny expression on my face now, but the funny expression on my face now is that I think they even they appear as services. I think we might be able to do that. That would be. I'm seriously going to have to try that now. Also, as we showed in the demo, remember that route-based authorization can be tricky with federated services. Route-based authorization is actually not supported at present for egress traffic, and this is a thing where, again, the issue is that authorization gets enforced by the incoming proxy, and there is no incoming proxy for egress traffic. At the same time, it's pretty meaningful to talk about the concept that you would want specific egress controls for specific workloads, and not every workload has the same egress controls. The best way to deal with that right now is simply to take advantage of the fact that egress networks are namespaced and do things that way. So that's it. This is a QR code to Buoyant Enterprise for Linkerd and to Service Mesh Academy, so you can sign up for the next one. Let's see if there's any.
There is, for the next one, interesting topic coming up. Open telemetry in Linkerd. It's here.
Woohoo!
Yeah.
That'll be kind of fun. I was also going to grab the link to the full talk about egress that I did at KubeCon.
Yeah, grab that one. The other interesting thing, we didn't demonstrate it here, but Phil and I spent last Friday messing around with it. Federated services, if you've got multiple clusters with federated services that have multiple AZs, the Hazel load balancing works with that. So there's not a whole lot extra you got to do, really. It's a whole setup. Again, flat network multi-cluster, pod to pod, and your 3 clusters need to be in the same AZs, right? It just works. You just turn it on and it works. So you can keep traffic in AZ cross clusters using federated services on the front end, and it does the thing.
Which is pretty cool. We decided not to demo that because
more moving
because we're already an hour and 15 minutes into this.
You would never make it.
Yeah, never would have made it. So that's the link to the YouTube recording of the One Gateway API to Rule Them All talk. I stole a bunch of the slides for egress from that talk. That talk goes a little bit more in depth on some of this stuff. You also get to see in that talk where my demo completely and utterly failed at the beginning.
And recovered.
So if you want to see how things look when it all goes wrong on stage, go check that out. You'll have a good time with that.
We've got a bunch of talks from KubeCon. We had a high number of talks this year, way above the
which
average.
is really cool.
So go out to the CNCF YouTube, and if you search on Buoyant, I believe you should be able to find them. There's a lot of great stuff out there.
There's actually, let me check this before I put a link in, but I think you can just go to
there was a lot of us running around going to all kinds of talks, especially William and Flynn. Those guys were everywhere.
There was a lot.
Yeah, it was busy.
Anything else coming up?
218's down the road. We've got some cool stuff coming in that, so keep an eye out. But that'll be probably a little bit more when it starts to warm up here next year.
Yeah, that'll. If you go to that YouTube channel, you will see lots of links.
Yep.
To lots of things, like KubeCon talks, although you have to scroll down partway for those. Also, you get the KubeCon project updates, which are always kind of fun.
Yeah.
Finally, let's see. This is the main Service Mesh Academy repo. If you go there, there's a link in the README to this talk, the Linkerd 2.17 features talk. That's the easy way to find the source code there. I think that is about it.
Yeah, we'll see you next year.
Yeah, you've got like another minute or so to toss questions into the chat if anybody has any. Or I can't believe we're already saying next year.
Yeah, thank you for showing up. I know that December is a busy month for everybody, so.
Oh, yeah.
Thanks for coming and seeing what everything's about. And new great stuff in 2.17. Awesome stuff coming in 2.18. And that will be prior to KubeCon EU-ish, somewhere in that neighborhood. And just keep making it better.
And if everybody's really good and the stars all align, then my camera will work properly for the one on the 16th.
I think we know what to get you for Christmas.
Many thanks, everyone. Appreciate y'all showing up.
Yeah.
We will see you next year. Have a good one.